So we're kind of deep into technology, and not all distributed ledgers are actually written just on blockchains. There are ways to write distributed ledgers onto other types of technology. And here's Thomas Trowbridge. Come on up. He's the president of Hashgraph.
Thanks,
Thank you.
Appreciate it. Thanks, everyone. Thrilled to be here talking about Hedera Hashgraph. Who are we? It's a trust layer of the internet. We are a base layer technology. But first, let me talk a little bit about the founding team. And then I'm going to go into kind of what we do and how we're different. And I think it's it's a very complicated story. And I'm glad that I've got 2 hours to explain it to you all. We're going right through lunch. I hope that's OK with everybody. Actually, all right, maybe we only have 15 minutes. But on Lehman Baird, the chief architect here, fastest PhD probably in computer science and Carnegie Mellon history. Mance Harmon, also computer science background. They met working for the senior scientist of machine learning in the Air Force. And that was in 1993. They've had multiple startups since then. But they were doing machine learning AI back before most of us had even heard of it. Pretty senior team, all with significant technology background. So let's talk about the technology for a second. What is Hashgraph? Base layer consensus algorithm. Far faster than anything in the market, far more secure. Where do we stand? We have public speed tests, very transparent. We'll talk about them later. You can download the SDK. You can replicate the speed tests. We have a test net up in 4 continents. And we have 15 of our governing members who have signed LOIs out of 39. What will it be used for? Any type of application that's suitable for blockchain will work on us, and it'll probably work faster and be cheaper. And our pipeline of dApps is growing daily. So let me raise a question here. Who's heard of Hashgraph before today? All right, now then we're going to keep the hands up. How many heard of it 6 months ago? How many a year ago? All right, a couple people. It might surprise you to know that Dr. Lehman Baird has been working on this since 2012. It seems like it came out of nowhere. It sounds like it's the first time many of you are hearing about it. But this has been under development for 6 years. So Satoshi solved the problem of distributed consensus. But solving it at scale is an entirely different proposition. And that's what Dr. Lehman Baird struggled with from 2012. By 15, after years of trial and error, he'd architected a solution. In 16, published a white paper. 17, won our first institutional client. And in March of this year, we announced a public ledger. Importantly, the goal has always been to get to a public ledger. Governance is critical for us. And in order to get the governing members we wanted, it was important to have the validation of an enterprise client. And that's why we started with an enterprise client to show the technology was actually deployed and functional and not just a white paper. So what is Hashgraph? It's not blockchain. And I think what people, is sort of an open secret, is that blockchain is actually architected to be slow. If blockchain isn't slow, it doesn't work. The entire hash algorithm is designed to slow the transactions down, as we all know, because if multiple blocks are mined at the same time, and the community needs to come to consensus about which to add. And so everything we see around blockchain is about scaling solutions. How do you make it faster? So we see side chains, child chains, sharding. All of those are actually trying to get around the fundamental architecture of blockchain, which is slow. And let me repeat, all of those solutions present security vulnerabilities or make security sacrifices. Hashgraph does not. So what Lehman designed from the ground up is a directed acyclic graph. Now, there are other DAGs out there, but this is very different and has nothing in common with other DAGs you may know about. This comes to total consensus, not local. It also comes to finality. With a math proof, you can take to a bank. It's not a probabilistic finality the way blockchain has. It is an absolute finality. And that has lots of other attributes for scaling in terms of sharding we can talk about later. How does it work? Combines a gossip protocol with virtual voting, and I'll explain that a little bit more detail later. So, public ledger. We are one of dozens of potential public ledgers out there that are all vying to be the public ledger or one of the winning public ledgers. So let's talk about what do you need to be a successful winning consensus algorithm. We think you need performance, security, governance, and stability. I think we can all agree that those are things you need. Now, we may disagree on what performance is necessary or how intense the security protections need to be, but I think we can agree that those four are critical. And what I would add is that no widely used consensus algorithm today incorporates those four attributes. Not one. So let's go through them. Performance. Speed is required for consistent performance. If you don't have speed, even if you have a low TPS DApp, you are at the vulnerability of any high TPS app that hops on the network. And we've seen that with CryptoKitties. We will see it again. Hedera offers hundreds of thousands of transactions per shard, and I'll give more detail about that, and consensus to finality in seconds. Not minutes, not hours, but seconds. Security. If consensus algorithms grow to be as important as everybody in this room thinks they will, they're going to be responsible for trillions of dollars of value transacting. With that comes incredible demands on the security functionality of every network. These will be targeted for theft, for hacking, for DDoS, whatever you can imagine. These algorithms will be targeted from the DApp down to the consensus layer. So you need to have the highest level of security possible. Hedera has asynchronous Byzantine fault tolerance, which is the highest level of security. It's a term which goes back a decade in scientific literature. There are people who are talking about slightly nuanced versions of it, but if it doesn't say ABFT, it's not the same. And it's incredibly resilient to distributed denial of service attacks and resilient to threats other platforms don't even think about. Governance. Let's talk about governance. And this is a point I think we all in distributed ledger land are thinking about the broadest form of governance possible and what is the appropriate governance for these type of mechanisms. And I think the goal is distributed governance and fair governance. But what we don't talk about is that even when you're in blockchain and you're looking at some of the more successful blockchain widely adopted technologies, you actually have concentration. The actual algorithm of mining leads to consolidation. And we like to think of it as being fully distributed, but you actually have a significant concentration, and it's driven that way by how the mining rewards work. You also have foundations. And I'd argue a foundation, as laudable as its goals may be, is still not decentralized. So what is Hedera doing? We have open consensus, meaning consensus is achieved by, at scale, thousands or hundreds of thousands of computers around the world. But we've separated that from governance. And our governance is a council of 39 world-class organizations. And what will they do? They will set pricing, they'll set the technical product roadmap, they will deal with government relations, and be a general governing body, which is separate from how consensus is generated. And we felt that's an important distinction to make. Now, the question we get is, isn't that concentrated? Don't you have one company calling all the shots? And the answer is, it's an organization, yes, but it's comprised of 39 companies from all continents and as many as 18 different sectors represented. And a third of it will turn over each year. So it's diversified by sector, by geography, and by time. And additionally, if you do 1 over 39, it's 2.56%. And I would ask, what other governance model out there has the largest influence be less than 3%? And I don't think it's easy to come up with one. So while it looks that way, it's, for us, the most decentralized and best form of governance we could come up with. You know, one thing, I'm reminded of a quote by Churchill, which says, democracy is the worst form of government except for all the rest. And so I think of our governance council as this. We've spent a lot of time and effort to figure out how to make it as diversified as possible, and we continue to work to refine it. Now let's talk about stability. This is a topic that we get a lot of questions on. We are, right now, the community is open source, and that has led to terrific innovation, but it's also led to a lot of instability. When you combine open source with crypto economics, you have the ability to generate massive amount of value by forking successful existing protocols, and we just saw it happen the other day, and it will continue to happen. We think that forking actually leads to instability and is an impediment to significant dollars being spent in terms of developing distributed apps. If you're going to spend millions of dollars, you're probably less likely to do that if the base layer may fork immediately and you don't know which side to support afterwards. So Hedera is patented. The Hashgraph consensus algorithm is patented. And that's a real stumbling block for a lot of people. But backing up from that, we're releasing the code as soon as version 1 is complete. So the code will be released. Anyone can review it. We're not trying to hide it, but we don't want the platform to fork. And we think that there are plenty of options out there if you want to fork and develop your own version of other platforms. We want to offer the market something different, something stable, with a promise that there will be no authorized forks of this platform. And so we think that stability is something that people will really value. So other categories of consensus algorithms, with their attributes listed, I think the main point I want to take away from here is, first, we're distributed denial of service attack resistant. Most others are not. Whether it's DPoS, whether it's leader-based, which are sort of the most common competitors out there, they are subject to DDoS in a way we're not. Blockchain clearly isn't, but we then have fair ordering and fair timestamps. Every transaction on our network has a timestamp agreed to by the community in a transparent manner. No other system out there offers that. So how does it work? I'm not going to go into a great deal of technical detail, don't have a ton of time for it, but it combines a gossip protocol with virtual voting. Gossip protocol sends information randomly, incredibly quickly, and sends the minimum amount necessary to generate consensus. That makes it incredibly fast and also incredibly resilient. The virtual voting allows votes to be calculated without actually going through a voting algorithm where votes are sent over the network, so it's also highly efficient. What's the platform? Hashgraph consensus algorithm sits on the bottom, and then we have 3 services we're starting with. Cryptocurrency with native support for micropayments, file storage, and an EVM. So anything written Solidity will work on our platform. These are feature complete, and the test network is up now, and we're releasing the public APIs in a couple of weeks, so people will be able to begin building on a limited basis on the network. Use cases, I think you can all imagine the use cases which can be built on any platform, so I don't think we have to spend too much time on that. I will say it's micropayment. You can support micropayments natively here, and also could support time-limited business transactions. Let's talk about speed, because it's a fun thing to talk about. Bitcoin, we all know what that is. Cost anywhere from 70 cents to $20. Ethereum, 25 transactions, 17 to 25, 41 cents. Potentially, it sort of moves around, as we know. Then there's sort of the next generation. Unclear what the cost of that is, but those are going around 7,000 a second. So where are we? We're testing at 100,000 a second. What I should say is Lehman will tell you that speed is a lie. So speed depends on the number of computers, how geographically distributed they are, and also depends on the time to finality that you want. And so with those 3 caveats, these are some speed numbers that we've released. They're all in our white paper, and you can download it and actually replicate these tests. We're very transparent about it, but we're not done. We get up to, in a regional basis, 250,000 transactions in a second. What's the price? For a cryptocurrency transaction, 6 millionths of a penny. Why would you need a sidechain if you can do this level of transactions on the platform at that level of price. And it goes even faster than that if you stick to one region. This is a revolutionary platform. And one thing I didn't say earlier is that the more time you spend on this and the more effort you put in, the more you know about the space, the more revolutionary you realize this platform is. I want to talk a second about developer community and how early this is. Right now, there are 1,400 dApps on the Ethereum blockchain. That sounds like a lot, and it is. But let's take a look at where growth in mobile apps started. iOS versus Android. In 2008, there were 3,000 apps on iOS and 167 on Android. You guys have any idea where those numbers are now? They're a lot higher. So where did it go? Well, 2010, it got up to 400,000 iOS, 100,000 on Android. 3,000 doesn't look so big anymore. Skip forward a couple of years, you're 700,000 for both, tied. And where do we go now? 2.2 million and 3.5 million in Android. So I just share those numbers to give a sense of perspective in where we are in the distributed app growth phase. I think we're just in the 2008 number here. And if you think the right metric isn't these apps, it might actually be growth of websites in the internet. If you think about that, that started in the single digits back in 1991. And we're now approaching 2 billion. And so I think it's important and very relevant to realize how early we are and how early this whole space is. And think about the early leaders of the space in the 90s. Think about Netscape. Think about Internet Explorer, the market share those guys had, and where they are now. So why Hedera? We're fast, we're fair, and we're secure. So thank you for listening.